Recent study shows that DPP4 is expressed in human pancreatic beta cells. Therefore, we investigated the protective effect of teneligliptin on beta cell function and survival in response to high glucose conditions. We used INS1 and human 1.1B4 pancreatic beta cells, and here's the results. When INS1 cells were cultured in high glucose, they underwent apoptosis. However, the addition of teneligliptin increased the viability of INS1 cell. Moreover, the high glucose-induced downregulation of GLP-1 receptor was reversed by teneligliptin. These results show that teneligliptin has protective effects against high glucose. Next, we checked the effect of teneligliptin on insulin secretion. When INS1 cells were subjected to high glucose, the cyclic AMP pathway was activated, and glucose-induced insulin secretion was increased. And interestingly, teneligliptin enhanced these responses. Next, we checked the protective effect of teneligliptin against ROS. In high glucose condition, the ROS level increased, whereas reversed by teneligliptin. Accordingly, the ROS-induced degradation of SERCA2b was inhibited by teneligliptin. To further validate the relationship between teneligliptin and ROS, we checked the effect of teneligliptin to SIRT1 expression. And the ROS-induced downregulation of SIRT1 was prevented by teneligliptin. And as a result, the SIRT1-induced inhibition of P66 activation was also promoted. And these results are also confirmed by human pancreatic beta cells. Given that SIRT1 can be activated by cyclic AMP pathway, we asked whether teneligliptin's protective effects were mediated by cyclic AMP pathway. We used H89, the inhibitor of cyclic AMP independent protein kinase. As you can see, when INS1 cells were treated with high glucose plus teneligliptin plus H89, the protective effect of teneligliptin was completely attenuated. So in conclusion, teneligliptin prevents high glucose-induced oxidative stress and beta cell dysfunction by activating cyclic AMP SIRT1 pathway. Thank you.
감사합니다. Questions or comments? What do you think the mechanism is by which teneligliptin potentiated glucose-induced insulin secretion and cyclic AMP production? Because I would have expected a DPP4 inhibitor to be mostly active when you use an agent to stimulate, like GLP-1, and then preventing the breakdown of GLP-1, but not by itself.
Well, we presented the SIRT1 as a key factor of your question, and teneligliptin reduced high glucose reduced ROS, and in following, SIRT1 was not downregulated by ROS.
Okay.
So the P66 activation was inhibited by SIRT1. SIRT1 inhibits activation of P66, and I think that's the mechanism.